The driving question behind this week's experiment was, what does emission intensity depend on and what does it not depend on? The hypothesis being tested was that emission intensity is completely dependent of energy input and that it is completely independent of the emitting substance. So, what exactly is emission intensity in terms of emission spectroscopy? Emission intensity is proportional to the number of photons emitted from a substance. The more photons emitted at that wavelength, the higher the peak on the emission spectrum. It's like trying to shoot wadded up pieces of paper into a wastebasket. The more you shoot with the proper amount of energy to get into the basket, the higher the mountain of paper becomes. There still will be some pieces of paper surrounding the mountain. These are the photons that were emitted at similar wavelengths, but not the maximum wavelength of emission, so their intensity is not as high. Depending on the energy put in, the base of the peak can be wider or narrower, just like how if you throw with less energy, the paper will land farther from the basket.
The energy for the excitation of electrons was supplied through a chemical reaction. The emission intensity is dependent on the energy input because the more energy you input, the more energy the substance can absorb, and thus the more energy it can emit. Thus, higher energy input would correlate to higher emission intensity. Emission intensity is also dependent on the properties of the dye. The red dye is larger and has more electrons, so it has more energy levels than the green dye. Thus, when the red dye absorbs and emits electromagnetic radiation, it will be emitting over a larger range of wavelengths of energy because there are more ways for electrons to move different energy levels in the red dye than the green dye. Since red is emitting more wavelengths of lower energy photons, the intensity for each of the wavelengths would be lower compared to the green, which emits a smaller range of higher energy wavelengths and thus emits more photons for each wavelength. Thus, the intensity for green is much higher than that of red, but red emits a larger range of wavelengths. Additionally, intensity is a measure of the rate of photon emission. So according to our data, green is emitting photons at a much higher rate than red, which can be attributed to how the green molecules is symmetrical and can more readily absorb and emit light. Ultimately, intensity depends on the properties of the dye, the rate of light emission, and the energy input.
When the red and green dyes are separate, the green peak has a larger intensity than the red peak. As we can see, when the two dyes are mixed, the red dye has a larger intensity than the green dye. This is due to the fact that once they are mixed, the red dye absorbs the energy that the green dye emits. Because of this, the red peak will have a larger intensity than the green peak, which is what we see. An example of this in real life is something that we see every day. Every child is somewhat a mix of their two parents. Even though we are a mix of our two parents, our genes still contain the traits from our mother and father. Similarly, the orange dye, the child, was a mixture of the red and green dyes, the parents. But the orange dye spectrum still had peaks of high intensity at the same wavelengths where red and green had their lambda maxes.